Hello and welcome to Psych319, Chapter 5, Part 1. This lecture is all about short-term memory and working memory. So we all have an intuitive idea of what memory is, but psychology, of course, has a more clearly defined concept of what memories are. There's several types of memory. But how do we approach it? Is it a behavior? Do we look at the types of things we can remember and how it affects behavior? Is memory a location? Is it something that's stored in the brain? How is it represented in the brain? How are memories formed? How are they retrieved? And how are they forgotten? So some basic vocabulary to get us started here. When we talk about memories, we talk about memory storage. And a storage is not necessarily a location like we think of when we think of storage, but sort of a concept, kind of like the idea that a memory would be stored across a network of neurons. So it's obviously stored in the brain, but you don't have a memory location in your brain. Uh, all of your brain is basically essentially one big tape recording machine that's designed to store memories and experiences. So it's what network of neurons becomes active for particular memory. And also the thing that the item that is stored we sometimes call a memory trace. You'll see that referred to in future slides. Also, how do we memorize things? So recording or storing a memory is called encoding. And trying to recall a memory is retrieval, bringing a memory into conscious awareness. And there are two ways of doing this, via recall or recognition. And recall I like to call fill-in-the-blank memory. So it's coming up with a memory from your past with no cue coming from the outside world. And this is distinguished from recognition, where there's a cue from the outside world that sort of triggers your memory, which makes it easier to recall. We call the recognition, I like to call the multiple choice memory. So one you get to choose from a number of categories, the other have to come up with the idea wholly on your own. And of course forgetting. Well, forgetting is pretty intuitive. It's the inability to retrieve a memory. I want to talk a bit about one of the more famous patients in psychology who died actually a couple of years ago now. His name was H.M., but he's probably the most important patient in all of psychology. He had, I believe it was epilepsy, and he underwent a surgery for radical surgery at the time to try and eliminate the seizures. And they removed both of his hippocampi on both sides of his brain, and the hippocampus is a part of the brain that's responsible for encoding memory. So basically it takes information coming in through the senses and routes it to places where it's stored. So he couldn't form new memories. He had the complete inability to form memories. He could remember everything from his past. His IQ was relatively the same. He was intelligent, could answer questions, for all intents and purposes, an intelligent individual, but he could not form new memories. So if you introduced yourself and walked out of the room in 15 minutes, he would forget who you were, and you'd have to introduce yourself again. And we learned a lot about how the hippocampus does its job of encoding memories through this patient. And there are two types of, in general, there are two types of memory loss. Amnesia is the loss of memory. There's anterograde amnesia, where you can't form new memories, but you can remember the past, like the patient HM. And then there's retrograde amnesia, where you can form new memories, but you can't remember the past. And those affect different brain structures. What I talked about just recently is anterograde amnesia. So HM, though, we learned something else about him. He could form new stimulus-response associations. So he might forget your name, but if you walked into a room and introduced yourself and you pricked his hand with a pin and it caused him pain, you leave the room and he would forget you did that, and then you did it again and again and again. Every time you introduce yourself, he would reach out his hand, try and shake your hand, and you'd prick it with a pin. But eventually, after enough trials, he would learn that you're a jerk. Of course, I'm just kidding. He would learn that he associated you with a painful pinprick, even though he doesn't actually have a recognition or recollection of having met you before. And so it seems that there's another type of learning that is a very low-level sensory learning, which we call perceptual learning. Yes, I sort of glossed over that at the end, but there's basically three types of memory, and we're going to talk about this in the upcoming chapters. Perceptual memory, or perceptual learning, short-term memory, and long-term memory. Here we go. Long-term memory are basically old memories, things that have been stored that you have already committed to memory and that are not going anywhere. And there are many types of long-term memory, including semantic memory, which is general knowledge and facts, what you tend to think of when you think of memories, like the capital of France is Paris. Episodic memories. Now, episodic memories are the history of events in your life, like episodes in a soap opera. They're things that happen to you in time. Those types of memories. And then procedural memories. So procedural memories is how to do something. And this can be distinguished from episodic memories. And the perfect example for this is learning how to write with a pencil. So many of you know how to write with a pencil. You know the procedure of how to write with a pencil. But you might not remember the first time you learned how to write with a pencil. So you forgot the episode, but you know the procedure. But you also know that pencils are used for writing, and that's semantic knowledge. So you can see how there's very different ways memories can be approached, and all of these are distinguished from each other. Short-term memory is very helpful for forming long-term memories. It's the process of rehearsal. In short, if I give you my phone number, 8675309, you repeat it in your head over and over and over again. 8675309, 8675309, and eventually, if you rehearse it enough, that short-term memory becomes a long-term memory, and you have my number memorized. And I already alluded to sensory memory, but it's a very short-term memory that's designed to keep essentially the activity in the senses preserved just long enough so that they could be encoded by short-term memory. If you didn't have sensory memory, the second a neuron stopped firing in your retina, you would forget everything that had just happened, and it wouldn't be possible to encode visual memories. So it's preserved long enough so that you can sort of take that information and pass it from short-term memory to long-term memory. And a good example of this is when you close your eyes, the world slowly fades from view. The details of the world are lost. And that lasts about 1 or 2 seconds, and that's really about the duration of sensory memory. Some people estimate it as being as short as 50 milliseconds, and there are more quantitative analyses of these, but for now we could just say it's up to about a second or so. And then from that it becomes a short-term memory. So here's a model of memory. We call this the modal model or the memory systems model. And the idea is that there are several systems that are separated and they interact with each other, but they're distinct. So you have some environmental input, and that is processed by the senses, which activates the sensory memory. And then if you're paying attention to that sense or that modality, those sensory memories enter into conscious awareness where you can rehearse them. And that rehearsal process is short-term memory. And through rehearsal, those eventually pass into long-term memory where they can be retrieved. So information is preserved in sensory memory and passed to short-term memory. I guess this says exactly what I was just saying. So let's skip ahead. So I'm going to give you a couple demos of sensory memory. I'll present an array of letters, and I want you to write down as many letters as you can remember. I'm only going to present it for about a second. Here we go. Okay, pause tape, write down as many as you can, come back. Now if you're back, let's go on with the next demo. I'm going to do the same thing, but this time don't write anything down. Ready? Here we go. Now I'm going to ask the question, was there an A or a B present? Did you catch it? All right. Last time we're going to try third round here. I want you to remember as many letters as you can and write them down like in the first try. Ready? Here we go. All right. Pretty tough, that last one. So if you performed in a stereotypical fashion, the recognition demo with the cue, where I asked you whether there was an A or a B, was probably the easiest. You either saw the A or the B, or you didn't. The recall demo was probably slightly harder because you had to recall all the letters in the array rather than just recognizing whether there was an A or B present. Recall is more difficult than recognition. And the third demo involved a sensory mask. So after I presented the array of letters, I presented a bunch of number signs which masked out the sensory image that you were receiving. So in a sense, I was disrupting your sensory memory, and that was probably very hard. Most of you probably did not perform good on trial 3. And this tells us a lot about how sensory memory works, or perceptual memory. New information is constantly coming into our senses. And anytime new information comes into our senses, it erases the previous uncoded trace, the uncoded memory trace. So, you know, when we're moving through the world, we have a lot of visual information that we're exposed to, and we have to process it very, very quickly. So whatever's coming in second is going to erase what came in first. Presumably, we've already encoded and analyzed that information, and we can throw it away and process the second batch of information. So if visual streams are very related, the brain has some time to encode them. And I think your book goes into a little more detail about this, but you can gloss this point. But the idea is that you can have things that persist over multiple waves of information from first trial to second trial to third trial and so on. So it's not like we're viewing things in a lightning storm or a strobe world where information is taken in snapshots. We have continuous representations of information, but in general, when we introduce something that's new into the world, it will, if it's unrelated to the information that we just saw, it will erase the information that we just saw. And if that information is suddenly replaced or erased, before it's encoded, the information is lost forever. You can't get it back. Sensory memory is not a long-term store. If it leaves sensory memory, it's gone forever. And then the last bit of vocabulary here, the sensory memory, we call it the icon. And now an icon, if you look up the strict definition, is really a place mark. And that's what the sensory memory is doing. It's merely holding a brief representation of the world in place, just long enough so you can encode that information and pass it forward. So thus the name the icon. And now we have a similar thing in other senses as well, but I'll only talk about audition, hearing. The echo is the same as the icon, but it's the hearing. Sensory memory is different for audition because if you think about it, vision, we're processing information over space and we're doing it very quickly. In hearing, we're processing information over time. You don't understand what my sentence is about until you reach the end of that sentence. So the sensory memory for the echo has to be quite long. It's on the order of many, many seconds in order to preserve that auditory information so that we can make sense of it. And it just means that we evolved to understand language in that way. So I just said that. Yeah, okay. So I'm going to stop here and we'll continue in the next slide.